So hi all, this is a session of decision trees using RapidMiner. So this is one of the earliest example that we have seen before. This is the Titanic dataset. As you all know how you know the Titanic dataset. So go to the samples, and if you take the Titanic, just a second, let me scroll a little bit. Yeah, so this Titanic training dataset. So you could see that the age, the passenger, the sex, number of siblings, these are the parameters which you have, and this is the survived. Okay, so this is the supervised learning training set which you are using, and this is the decision tree. So we are not using any, we are just taking the decision tree operator and using it. So when you simply look at it, so this is the tree which is formed. Okay, so this is this decision tree which is formed, and this is the graph. So you have got your root node, and when if it is female, then what is the number of the children. So you could just go back and you can identify this. So this is the tree format, but in the description format, and this is the graph. Okay, so hope you understood this. And then going back to a little bit deeper. So when you go back to the random forest, I told you, like, I have not taken the random forest in the class, but you can always try those for the, this is an operator which is available, and you can use that. So this is a golf data set, and you are using the random forest. So here the number of the trees, I am giving it as 100. So I want 100 different trees. So I already told you, like, forest means there will be a lot of trees. So you can have a set of trees. So you're providing the number of the trees here. And here these are the ones which we have learned: gain ratio, information gain, gain index, accuracy list measure. So in that information gain and gain ratio we have seen. So here we are using the gain ratio in random forest, and the depth of the tree can be maximum 10, and the confidence voting. So the voting strategy which is using is confidence voting. So whatever it is, so we are giving it on to the model. So we are training the model, and then we are applying the model and seeing whether it is able to give us the accurate results. So that is what we are trying to do. So here if you could see that this is our this is the this is the older one, sorry for that. Yeah, so this is the one which we are basically using here for the golf data set. So wind, temperature, so these are the attribute weights which we got, and we have applied the model. So this is the actual one, and this is the predicted one. Okay, so this is the actual one, and this is the prediction one, and accordingly we have asked the model to form 100 different trees. So these are the 100 different trees which we have formed as part of the random forest. So this is how the random forest work. And there is another example here. So this is also the same thing, but we have explicitly, so we are using the polynomial data set. As you know that there are 5 different attributes for the polynomial data set, and we are splitting the data. Here we are splitting the data with the 70-30 split, and here also we are using the random forest. We are applying the model and all the same. So when we do that, here you could see the prediction. This is the original label, the actual label, and this is the prediction. And the root mean square is 53, and these are the various model trees which are formed for this 5 different attributes in the polynomial data set. Okay, so these are the different examples which I do have here, and yeah, I wanted to talk to you about one major concept called ensemble modeling. So ensemble modeling, as I told you, is very simple. So if you want to compare the data set with the different models, okay, that could be done. Okay, so this is one simple example which I have done using the decision tree and the random forest. So we have taken the polynomial data set. We have split the data as 70-30. So we have split the data as 70-30 here. So the training and the testing set is 70-30, and I'm just multiplying this so that I could apply it for the decision tree, and also I could apply the same data, the training data, for the random forest as well. Okay, so this is the training data is multiplied, and it's just the same data is passed to the random decision tree and the random forest. So 2 different models, and I have applied the model, and the performance is calculated. Now I want to know whether the testing set, how these 2 models will work on the testing set. So I'm again multiplying this into, and this is the testing set which is passed. The same set is actually passed as the testing set to the data, and so the 30 will be passed here to see how it is actually working. So when you look at it, when you run this particular model, you could understand the performance vector of performance vector of the decision tree is given here, the squared error and the mean squared error is given here, and this is for the random forest. So this is for the decision tree and this is for the random forest. So whichever has got the minimum error, basically we can go for that particular model. So this is the comparison which you could do. So here it is almost 88% error is there, and here it is 53% error is there, 53.6, almost 54% error rate is there, percentage is there. So basically you could go for the random forest. Now these are the attribute comparisons when this is just the attribute weights which is actually given for each and every one. This is what I want to tell you. So there is something called ensemble modeling which you could basically do in order to compare different models, and this is another example. Yeah, so this is another example where you do have you are trying to you are taking the sonar data and you are splitting the data 70 and 30, okay, and then you have something called voting. So voting in the sense like voting is also kind of a cross validation. So this is nothing but the cross validation, but you have just renamed it as voting, okay. So in the cross validation, what you have basically done is that you have actually given all the three different models, okay. You have something called voting. So here it's just like your cross validation, but you don't have this training and splitting, training and the testing done separately in this, but instead it will just simply vote, okay. It will give you the vote of the different models that you're going to try. So when you click on the vote, you will have these three models are basically compared. So you're taking the data, you're splitting the data, and you are actually passing the data through three different models, okay, and then you are actually the results are basically passed on to the apply model and the performance is calculated. So this is basically operator like cross validation. Like cross validation, you could just go inside the same way the vote can, you can go inside the vote operator and you can bring in the different type of operations which you have to perform here. So these are the three different things. This is also a different kind of ensemble. So vote is a different operator which is here. So when you run this particular model, you could see the confusion matrix which is generated, and you could also see the precision, the recall, and this is the AUC curves which is basically generated for different ones, okay. So this is the one which is basically more useful for us. So when you look at it, you could see that three different confusion matrices which is formed, okay. So on the three different confusion matrices, one is for the decision tree and the another one is for the what to say the random forest, and the other one is for the KNN matrix. So which one has got the highest thing which you could see here, and you could actually take it out. So if you want to show the accuracy in a more detailed way, okay, it is also possible. So that what you have to do is that you could just go here and you can give it into the apply model. So here whichever has got the highest one, that is only actually getting displayed, okay. So here when you look at the results and when you look at the description, you could see that yes, so whichever has got the highest one is actually like 90.19%. So this has got the major vote, okay. So this is the best one which is sorry, this is the best one which you could actually take. So like that you could actually try and understand which method is good. So when you look at the results, you could say that all the it's basically it's an average, okay. It's an average of all the three has been taken, and if it is classification, it will take the best. So this is how it will work for the ensemble voting, and I think that's all for the day. So this is ensemble. So just understand that in ensemble you can either use the ensemble operator or you could use this vote operator in order for comparing with the multiple models. Thank you so much. If you have any issues, please let me know. Thank you.